This video is going to be interesting because we are going to write a program, or let's say a bot, that can play the T-Rex game of Google Chrome automatically. We'll be writing this program from scratch step by step, and this is going to be a computer vision tutorial for complete beginners. So without wasting time, let's get started. Our first step is to install Python in our computer. In the description below, I have put the link to the download page. You click over that link and you'll be navigated to the download page. Click on that download Python button and your download starts. After completion, click the setup file and installation window pops up. You need to add Python to path because we want the Python to be executed in command line too. Now we click on install now and wait for it to complete. Now hit Windows R from the keyboard and type CMD and hit enter. Type python -- version and it will output the version of the Python you have installed. Now our next step is to download Visual Studio Code for writing Python codes. If you already have other IDEs of your choice, that's fine. If not, then I would recommend Visual Studio Code as it is free, fast and easy to use. I have put the link of download page in the description below. Go to that link. Now click this button to start downloading it. Follow the video and install it. After installation, we have to install Python extension as it will help us with autocomplete, IntelliSense and different other features, making Visual Studio Code as an excellent Python editor. For that, open the Visual Studio Code and go to the extension and search Python and install it. Our next step is to make the project workspace. Let's make a folder called dino and open it with Visual Studio Code. Now we need to make environment here because whatever Python packages we install, it should be limited only to this project. So for making environment, we need to go to the terminal and then type python-m benv and the virtual environment name. For this time I will use ben. Okay, it's the name that you can give by yourself, and you can give any name. Here I give ben. Now we can see that a ben folder is created here. For activating the environment, let's type this and hit enter. Now we have set up the workspace ready for programming. Whenever we open the project folder in Visual Studio Code, don't forget to activate the environment, okay? Now we'll install necessary Python packages that we'll use in this project. First of all, we need to install OpenCV, and then we need to install PyAutoGUI. Again, we'll install Pillow. Now we are ready to code our bot. Let's make 3 into 3 pixel image using MS Paint. The pixel at first row and first column needs to be blue, and let's make it blue. Again, let's also make the pixel at first row and third column blue. Again, let's make pixel at second row and second column as green. And finally, we'll make bottom right and left pixels red. Let's save the image in our project workspace as img. Now we'll make a Python file app.py in our project workspace and import OpenCV. Let's read the image we have created. And in the next line, print img. And for dimensions, we'll print this. Don't forget to save the Python file for running the current code. We need to save it. Okay. Go to the terminal and type python app.py and run it. It will print a numpy array of 3 by 3 by 3 dimension, which is 3-dimensional. Okay. To understand this, let's look at this image. And we'll convert this image into the form of array. Put the color blue as B, white as W, and red as R. Here array is just 2-dimensional, but while printing the image we got 3-dimensional array, right? Actually, each pixel is not a single value. It is an array of 3 color values: blue, green, and red. So these 3 values can make any color. So for the red color, R equals 255, G equals 0, and B equals 0. For green values, R equals 0, G equals 255, and B equals 0. For white color, R equals 255, G equals 255, and B equals 255. Now let's replace RGB and W with array BGR. And now we get 3-dimensional array of images. That's what we got when printing the image. To print the color values of first pixel, let's say, type print img0, 0 and run the program. Here you will see it prints out 255 0, 0, right? So it prints that because it's a deep blue color and the first index of the array is for blue, right? So it's 255 and rest of them are 0, 0. Now let's show the image in window. Do cv2.imshow and window name, comma, and the image we want to display. If we run the file, image is not displayed. Why? Because program closes as soon as the image is displayed. So we need to wait until user hit any key. For that, we have the command cv2.wait key 0. Here 0 means wait forever. Run the program again. Now we can see that the image displayed. Hit any key to close it. Also, I want you to know that cv2.wait key 0 returns the key you entered. For that, let's put it inside print statement. Again run it and hit any key to exit. Here in the terminal, you can see that it has printed the key that I have pressed. We have to get the image of T-Rex cam window. To do that, we can take a screenshot of the window. For taking a screenshot, let's import image graph from Pillow library. And grab the screenshot by this command. Pillow library also allows us to display image. Just type image img.show. Now run the program. What if we want to grab the screen considering particular region? For example, let's crop the screen at this region. Now we'll set bbox equals top left x, top left y, bottom right x, and bottom right y. Again, save the Python file and run the program. Okay, we successfully cropped the screenshot. Now let's try to display it with OpenCV. While running, you will encounter error. It's because img variable is a pillow object, but we need to convert it into numpy array. So to convert it, do this. While running it, you will see the color not matching with the screen. Why? Because pillow works as RGB and OpenCV works as BGR. So we need to convert RGB into BGR. We can do that by img equals cv2.cvt color img comma code. Okay, code is cv2.color rgb to bgr. Again, let's run it. Now screen color matches with the screenshot image. But to play dinosaur scan, we need real-time screen record. For screen recording, we need to grab the screenshot all the time. For that, let's make a while loop which runs forever. Put the screenshot grabbing code inside the while loop. It will be a good idea to have a separate function for grabbing the screen. So let's call this grabbing code and make grab screen function and paste the code there. We need to return the image. For bbox, let's pass it as a parameter. If no parameter is given, bbox should be none. Now in the while loop, simply grab screen by this code and if we want to crop the screen at particular region, pass bbox as argument. For breaking the while loop, put this code. If user enters Q, then while loop is broke and the program is closed. Let's run it, and now we have just made a screen recorder. We can also save this recording, but we are not going to do that now. For locating the T-Rex, cacti and the bots, we need to save the images of them. The image size should be same as it is in the screen. You can take a screenshot and just crop the object we want to locate. And save it in the image form. If it's time consuming, no problem. I have put the project link in the description below. You can download it and then copy the objects folder from there to your project workspace. Now we have to make object of all the images. We take the path of the image and make object which contains properties of the object like width of the object, height of the object, location of the object in the screenshot, and the image itself in the numpy array form. So let's make a class object. Whenever an object is initialized with argument as path, we read the image in grayscale. 0 in the second argument means reading the image in grayscale, okay? And save all the necessary properties, and location is none because we don't know the location of the object without matching it in the screenshot. It is better idea to put the functions and classes in the separate file. So got the grab screen function and the object class and paste it in code.py. To access those functions and classes in app.py, simply import them from core. In app.py, we need to create player object, which is T-Rex, and list of enemy objects, which are bots and cacti. In Chrome browser, after some score, we get black screen. So we have two players, One is dinosaurs at white screen and another is dino at black screen. So let's put player as a list, and object at first index is for white screen and second index is for black screen. Again do the same thing for enemies. First index is for enemies on white screen and second index is for black screen. At the beginning of game, our player and enemies are at white screen. So let's set player index and enemy index to be 0. Now it's time for matching the object in the screenshot and producing the location of the object. To make it simple, let's just screenshot the dino game and open MS Paint, paste it and save it as screen.png inside the project folder. Make a test.py file. Now we are clean to go. Import CV2 and from core import object. Here in the screenshot it has only 2x in it. So let's make object for player only and let's read the screenshot in grayscale. For matching the object, we have a simple method in CV2 called match template, and here at the first argument we put the screenshot where our object is located. At the second argument we put the object image, and at the third argument we put the method or formula for matching. Generally we use normalized correlation coefficient for template matching. Here the result will store the correlation value of each pixel. If object is matched at high accuracy, that pixel will have high value close to 1, and if not, low value close to 0. And when we display the result image, white color or closely white represents high chance of object matched at that location. For matching the object, it sorts from top to bottom in the screen image. If screen has small size, it takes short time, and if it has big size, it will take long time. Here we don't need this result image, right? We need the location of the object, which is top left coordinate and the bottom right coordinate. In the next step, we will use cv2.minmaxloc, which returns maximum correlation value, minimum correlation value, coordinate where there is minimum correlation value, and the coordinate where there is maximum correlation value. We will save the location as startloc, which is the top left coordinate, and bottom left coordinate will be the top left coordinate plus width and height. We want save the location if object has lower correlation value. For that, let's write if maximum value max val is greater than 0.8, location should be startloc, inloc, else location should be none. Let's print the location and run the file. We get the location printed. Now we will make a rectangle at that location. Simply do cv2.rectangle, screen image, location at top left and location at bottom right, color of the rectangle as blue, and then thickness as 2. Now replace rest with the screen image and run it. Okay, that's awesome. We successfully did the object matching. Now let's put it in the match function with argument as screen image and the object image. Let's again run it and see if it works. Okay, fine. Now we will integrate this match function in core.py. But it is better idea to keep match function as method inside object class. So let's paste it in there, and now we can directly get object image as self image. So remove it from argument. We will store location as self.location. Let's also return true if location is found, else as false. Now whenever we call match function or method, if location is found, it will be saved as location property in that object. Now we can simply get the location by object.location. Our next step is to crop only the region of the T-Rex cam. Why? Why do we need to do that? It's because matching objects costs time. So decreasing the region will make it fast. Let's see how to do that. We will not do this loop until we get the T-Rex cam window. For that, let's make an infinite while loop. Grab the screen and convert it to grayscale. Whenever player is located, it means we are ready to get the location of the game region. To get the top left and bottom right coordinate of the region, we can do some hacks. Let's see how. For the top left x coordinate, we can subtract the width of dinosaur from the dinosaur top left x coordinate. For the top left y coordinate, we can subtract the 3 times height of the dinosaur from the dinosaur top left y coordinate. For bottom right x coordinate, we add 14 times width of dinosaur to the bottom right x coordinate of the dinosaur. For bottom right y coordinate, we add half the dinosaur height to the bottom right y coordinate of the dinosaur. Now screen start will be top left x comma top left y, and screen end will be bottom right x comma bottom right y. After we get the screen location, let's break the while loop. Now we are ready to play the game. To start the game, press space key using PyAutoGY. It's just that simple. Now in VBox, put the screen start and end. And test the code. Here, after grabbing the screen, let's convert it to grayscale, as we are using grayscale image for template matching. Keep the original image in separate variable, example imgo. Now we need to check if we are playing in white screen mode or black screen mode, right? For that, if player for index 0 is matched, it means we are playing in white screen mode. So let's put the player index and enemy index as 0. Else, if the player of index 1 is matched, it means we are playing in black screen mode. So let's put player and enemy index as 1. Here we have already run the method match. So dinosaur location is saved in the player object, okay? Now we can make a rectangle if player is located. Also, we have a lot of enemies out there, so take enemy in for loop, and if enemy is located, make rectangle for that too. Now let's run the program and see if it works. Cool. We have successfully located player and enemies in the game. Our next step is to jump when enemy comes near to the player. For that, we need horizontal distance and vertical distance, and also set the distance threshold. When horizontal distance is less than distance threshold, player needs to jump. But for bots that fly high, we shouldn't jump. For that, when vertical distance is less than 2 or negative, we can jump, else there will be no jumping. To know horizontal distance, we can do this, and for vertical distance, we can do this. Also, after player do the jumping, we don't have to check for rest of enemies. So let's break the for loop. It is not necessary but would make the program fast. Now let's run the program and see if it works. But as the time increases, player runs fast, right? And the player needs to jump from the large distance. It means over time we need to increase distance threshold by some rate. Now we need time control in our program. For that we have to import time library. When the game starts, we will set the start time equals time.time and previous time equals time.time. Time.time returns seconds since January 1st, 1970. Now every second, we need to increase the distance threshold by a rate. Let's define speed rate equals 1.4. If time.time, or let's say the current time is greater than the previous time by 1 second, then we will increase the distance threshold by speed rate. But we need to stop after some time. So if current time is not greater than start time by 180 second, then we can increase distance threshold, or we won't. Also, we can increase distance threshold only when we are in the game window. Now previous time should be equals to the time.time. I think we are done with the coding part. Let's check it. Okay, we have just made a boat successfully. You can try the same concept over other games and make a boat. Thank you for watching the video and see you in the next video.